Hello. I think I had a tweet that people should have seen. You have a chance to win, a chance to work with me at Christie. Christie, these are Christie projectors up there. Yeah. You just have to answer some skill testing questions. What is the reference? What's the obvious cultural reference here? Beatles. What's the non-obvious cultural reference? Good job. Right? Yeah. Very subtle. It was the 4 dots. The 4 dots give it away. All right. Talk to me after. There's further skill testing questions later. Really, that's all I need. If you can do Star Wars references, you fit right in. All right, let's go, everyone. You say you want to write a function. Well, all right. You don't want to write a function. You don't, right? You've looked at code before, right? Here's some code. What do you want to do with this code? You want to add a feature. You want to fix a bug. You don't want to write code. You don't want to write a function. You just want to write code, right? By the way, yes, projectors. You're going to see a lot of slides that say projectors and cameras and stuff because that's what I do. We make projectors. I do this stuff. It's called projection mapping. You put projectors on a thing. You put patterns out. You look at it with cameras, and then bam, you project onto the object, and you figure it all out, right? So that's what I do. Did I mention you could come work with me? All right. So let's say you've got this function, and for some reason you need to add this feature, fix this bug, where you need to special case for north. Why north? I don't know, maybe because CPP north. And we need to know, is this projector facing north? For some reason, this is really important, and this is going to fix our bug. It's going to add our feature. This is going to be great. So what do you do? How do you do this, right? So you probably projector something, get the pose, and the pose has got like the position and the orientation and stuff I don't remember, like arm placement and Sears catalog, pose stuff. No one? No one Sears catalog? And then you get the yaw. There's like multiple ways to do orientation. There's like XYZ rotations, there's yaw pitch roll, there's quaternions, and one of those is correct, but we're going to use yaw pitch roll. Quaternions is the correct way. So, you want to know if we're facing north. Maybe north is at 0. You do some math, blah, 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 blah. Hey, it's facing north, right? Here we go. We're doing well. And it's like, oh yeah, but 0 or like left of 0, right of 0. Now we've got this projector's facing north. Great, we're on our way. And it's a little ugly. Maybe we could make a variable to take care of that repeated code there. But half of you are not going to do that anyhow. You're just going to use the repeated code. And then it turns out you got like the old projectors, they need a bigger tolerance than the new projectors, and so you just add some more code there, right? And all's good. You're gonna fix this bug, everything's fine.
How did this happen? We're smarter than this. Apparently not.
Right, the code's actually already not looking too great, right? And you start to ask yourself, am I a good programmer? Are we the baddies? So the question is, how did we get here, right? It was just like, I just wanted to add a little feature. It was no big deal. How did I get here? And it's like, you get here one step at a time, right? I wrote this code in 10 seconds, in 1 minute or something. No, this code happens over time, right? The first person added the 1 line of code, and the next person added another line of code, the next person added another line of code, and now the code is here. And each step of the way, was just a little tiny step. It wasn't a big deal. It was fine. But what you get is this thing called complecting. And
let me explain. No, there is too much. Let me sum up.
All right. Let me sum up. Rich Hickey made a language called Clojure. He did a really good talk called Simple Made Easy. And in that talk, he really loves to go to the dictionary for whatever his talk's about, and he looks it up in the dictionary. And simple and complex both come from the same Latin word plecto, to mean a fold or a braid or like intertwining. Simple is one fold and complex is many folds. And easy comes from adjacent, like beside you, close at hand. So people mix up easy, simple and easy. You say, oh, that's so simple, it's easy. These are two different things. Something can be the result can be really simple, but it could have been hard to get there or something, right? You can see beautiful code that's simple. It took a lot of effort to get there. Simple and easy aren't necessarily the same things. And we really like this idea of easy is just, it's right here, it's close at hand. And then he brought back a word, basically, complecting, which is this old, archaic word, but you can see the meaning of it, right? It's the process of making something complex, right? The interweaving of the braid or whatever, right? And then it's a really good talk. You should go watch it. Not right now. And then there was another talk by another speaker I like. It was just a lightning talk, and you can tell it's like a take on that talk on how complecting is the easy path, right? Look at that code. Every step of the way, the easiest thing to do was the one that makes the code more entangled, right? The easiest thing to do is to add just one line of code, fix the bug, move on to your next task. And you'll find, this whole complecting made easy was a 5-minute silly lightning talk, but man, it is my big epiphany of programming. I spent a lot of time trying to figure out why code looks bad. And I think this is it. It's like every step of the way, the easiest path is not the right one. Like this code here. Like even this, it's easier to cut and paste that line of code than to make a new variable. If you make a new variable, you gotta make a variable name, and that's hard. We all know naming is hard, so you just cut and paste the code, right? So not writing a function is easier than writing a function, right? You've already got code. It's so rare that you start from a blank file and you just start writing code, right? No, there's already code and you're adding code to it, so you don't even make a function. Thus, the whole thing, you want to write a function? No, you don't, right? We should work on that. So, we want to be good programmers. We want to write functions. I'm going to claim that will help you be a good programmer. So what are we going to do? We've got this if projector is facing north. Know what we're going to do? We're going to copy that line. We're going to put some underscores in it. We're going to put brackets on the end of it. And maybe, syntax that up a little bit. And then delete all that code. That's how you write a function. Look at that, eh? Isn't that great? And then we're going to remove the comment, right? No, we're not. I lied. We're not removing the comment. We're fixing the comment. We all knew that it was projector facing north, blah, 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 blah. We don't know why we're asking the question. And nothing about the code is going to tell you why we're asking the question about north. And my favorite comment word is otherwise. We're checking for north, otherwise, the thing over there crashes, or otherwise you're pointing in the wrong direction, you don't find the screen object you're looking, I don't know. I mean, it's the made up examples. I really don't know why we're checking north. We're checking north, otherwise we're at a different conference. This one's called CppNorth. So that's not even anything to do with functions. That's just my favorite comment word is otherwise. Just bonus comment for you. And, speaking of functions and naming, don't include types in your function names, basically. String from int, no, you just call it toString, right? You have to include the return type in the function name maybe, for something like toString, but the param types you should know. They're 17 is an int, we all know that. All right, so look, we've got a function. It's beautiful. Success, I think I'm done. All right, good. Got a couple more minutes. All right, time for a koan. All right, do we understand koans? I always have a definition in my head and I can never think of what it is, but short story, hopefully there's enlightenment at the end. You should have to meditate on it. In this story, we start out with the Padawan, the learner, is asking how to read the config file. And the master replies, oh, there's a function for that. Well, Padawan's like, well, okay, great. What's the function called? Well, guess. Why don't you just guess what the function called? The function to read the config file, what's it called? Read config, yeah, that's pretty good. Read config file, you know, whatever. Could be some other kind of config. This is a config file. I like it. Very good. And the master was like, yep, that's right. You just got to pass the file name, reads the config file. Great. What's the path to the file name? There's a function for that too. Awesome. Great. Just for the config path, there's a function just to get the path. Yep, yeah, just call a function. So maybe read config file, get config file path. Master's like, OMG, that is it exactly. That is perfect. Anyone enlightened? Yes? Do you want to tell me your enlightenment?
You'll have to get there yourself.
That is so correct. So correct. This is somewhat based on a true story. I did this to one of my coworkers. These functions don't exist. The idea was you would like these functions to exist, so write these functions. Like this, you had questions, you wanted things you needed solved, things you needed. Functions are the answers to questions. And it's like, how do I blah? You call the function that does it for you. Where do I get the thing? You call the function that gives you the answer. Functions are great. They just take care of everything for you. You know, maybe later you have to write them, but right now you just call the function. It's awesome. Write the functions you want to see in the world. That's my little saying. You know, like these ones. So this is the same idea, right? We wanted to know if it was facing north, so we called the function, and it told us whether it was facing north or not. That's all there is to it. There's, you know, and some of you old timers might. I'm not looking over at Kate and Greg. we know who we are. Top down programming. So, you know, not a new thing. Just work your way down the code. Call the function. Later on, the other you might have to write the function, and that's how that works. Oh, another koan. This one looks older. I can tell by the font. In this one, the master is out walking their dog, and they stop by their Padawan, or whatever you would like to say, their coworker, their whatever, and stopped by for the visit. And the Padawan, of course, was, you know, supremely honored by the Grand Master coming by for a visit. And the master's like, yeah, you know, I was out walking the dog. You know, thought I'd stop by. By the way, you know, I looked at some code and I was just wondering why you passing in big common struct into this function instead of just passing in X and Y, right? And the student is like, well, big common struct, that's where we keep X and Y, master. And then the dog barks. Sorry, my dog's hungry. No, don't bother, right? No, don't worry about it. Dog's just hungry. And then, of course, the student is like, well, master, please let me feed your dog a feast. I will prepare something for your dog. I would be honored to prepare something for your dog. Nah, just open the fridge and let him take what he wants. cause for the enlightenment. Anyone? Anyone? These cones are, I don't know, I'm not even sure where they come from. They're just, we found them in the old scriptures and stuff. This is one of the first ones that was 280 characters. All the rest were 140, and then recently there's been a lot of 280 character ones. Not 279, exactly 280, no one knows why. Back to our function, as if this is in no relation to that Cohen. This function takes a projector. And you know what it does? It gets like one or two things out of the projector and then never uses that projector again. Because it doesn't really need a projector, right? Because if you pass in a projector, eventually this is it facing north function is going to, show a video or something. You've given it all the power of what a projector can do. And eventually someone's gonna call one of these functions and you're like, why are you calling that and is facing north? Now the answer is gonna be for good reason. Like, it fixes a bug, or something. And you're like, yeah, but it shouldn't be in this function. And you're like, well, I was in this function and I needed to fix a bug, so I just put the code right here, right? Because that was easy. This fixed the bug. Everything's happy, right? Because when you pass the whole projector in, it's close at hand, right? It's easy being adjacent, being close at hand. You've given the power to like, I could just, or maybe this, maybe the projector's not enough. Maybe I need something else. But hey, projector is owned by model. In our code, we've got a class called model and it's in all caps because it's model. It's got everything in it, right? If you can get access to model, then you've got the world, right? And so if you're in this code and you're like, oh, I just need the thing. So I'll just get from projector will give me the model or the other thing, and that'll give me the other thing, and then I'll get the thing I need, and then my code is great, and off I go. So if this function instead took the things it needs, instead of a projector, instead of a fridge, it just took the things it needed, you wouldn't be able to do that, basically, right? Now, maybe fixing your little bug that this line of code solved becomes slightly harder. Probably not, actually. It would probably just figure out a better spot to put the code. But having a function that only takes what it needs is a barrier to complecting code. It keeps your code separate. It forces your code to be separate. You just didn't pass that in. And now, passing another argument's not easy, which sometimes you complain about that. It's like, oh my God, I got to change all, I got refactoring tools for this and all this kind of stuff. You guys have now made it easy again. Like, I rely on it being not easy so that you don't just, make the easy change, which might not be the right change. I need you to stop and think about the change and keep things separate, keep that nice barrier. That's what functions are doing for us. Although this side is not quite as clean as it was, right? It used to just take a projector, because we're basically not quite doing top-down programming anymore. At the beginning, I was like, I need to know if this projector's facing north. So I call a function, hey, is the projector facing north? But now the function's like, I don't deal with projectors. I deal with like orientations and tolerances and stuff. So it's like, it's a compromise, that's okay. Or, why not both? You can have that is facing north projector function, but the real function that does the real work is the minimal function. And I like to call this code top down on the way down and bottom up on the way back up. Right? Because when you started, you wrote this function that took a projector. Right? That was on the way down. I need a function that tells me about the projector, so I write that function. But you wonder, what? Oh, yeah. Risk, you run this risk of complecting, so instead you work your way back up and you bring balance to the force and et cetera, et cetera. Because you look at what the function really needed. Hopefully it doesn't need the show video. I should get that line out of there. Hopefully it only needed the two things. And you see this all the time. Code that takes a parameter, and the first thing it does is take what it really needs from that parameter, and then does a function. And you're like, why did you just take the thing you need? My version of KISS, keep your stuff separate. Some people use a different S for stuff. All right, by the way, this talk is called Value-Oriented Programming. Because every year I give a talk and I try to understand and explain value-oriented programming, and I can never give that talk. And I realize whenever I try to give that talk, I end up talking about functions, so I'm giving this talk. But I should mention values, right? And basically, without giving that other talk, projector is an object. Orientation and tolerance, direction things, those are values. That's all I need to ever explain values versus objects, right? Projector's a thing. Projector has identity is actually the important part. Orientation, tolerance, you just pass those by value. It's like you don't care about their identity, you don't care about their address, you don't care about that exact double right there. You just care about the value inside the double, right? So that's values and objects in a nutshell. And one of these functions is testable, right? One of them's harder to test, right? You need to like mock out the projector or something. Like I'm not very strict on my syntax. Projector is probably a pointer or a reference or something. You can't. In my code, you can't pass it. Projectors are really big, right? They're like giant refrigerator-sized things. Those are small projectors, by the way. We got big projectors. So you can't pass a projector by value. You can't just, I would love it if I could just copy a projector that way. But no, you can't. You're always passing them by reference and by pointer and stuff like that. So, we are here in the song, by the way. Params with all that state. Had to find something that rhymes. You had to fit in the song. Projector is a lot of state that you didn't want to pass in. You just wanted to pass in the minimal state. All right. When you think of functions, you kind of think of this sometimes, right? This is kind of a mental model of functions. What's the difference between the left and the right?
Citation is visible. Number of columns.
Kind of side effects, yeah. The left takes an input, modifies it, and produces an output. The right takes an input, produces an output. The number 17 never changes. It's the number 17. You can count on it. So this is, I forgot to put the like dash, because I was gonna put dash question mark. I read this somewhere. Separate calculating from doing. And it's in a book, and someone referenced it, and I saw it. I didn't read the whole book, but I saw that, and I was like, yes. Something I was probably already subconsciously doing, but I didn't put the words together like that, so these are not my words. Separate calculating from doing, right? And the right-hand side is like calculating, and the left-hand side is doing. It's modifying something. So let's say we're doing this function that puts the star on the sneeches. These are Dr. Seuss references in case you're, surprisingly, basically in case you are not from like an English-speaking place. I realize that. If you're not native English speaking and you want your kids to learn English, buy them Dr. Seuss books. That's all there is to it. The star on machine puts stars on sneeches. Everyone knows this. We do these things to put a star on a sneetch. Probably use projectors and cameras to figure out the shape and size of the sneetch, I suspect. And as an aside, this function returns a void. That's it's just like returning void is a code smell. I'll probably come back to that. But like, more and more in my life, I'm like, this function returns void. That functions don't return void, functions return things. This function, though, does 3 things and then applies, 3 steps, and then the 4th step. The first 3 steps calculate, and the last step modifies. So let's have a function that does the calculation. That function is beautiful. It, like, you pass some stuff in, all those things it passed in are either values or const. The sneetch probably isn't passed by value, it's probably const ref. But it doesn't modify anything, it just gives you an answer. It gives you like the list of locations of where to put the stars. And then apply stars actually modifies things. So again, one of these is really easy to test. The blue one, in case you're wondering. Red fish, blue fish? No, red line, blue. And I love this idea of separating the calculation part from the apply part. You still might have I can kind of now live with the star on function that returns a void, because the main function, or at least a big chunk of the function, apply stars is probably complicated as well to get the stars onto this niche and everything, probably controlling some actuators and whatever. But, you've taken all you can that doesn't need to be, that is not modifying anything, and you've separated it out. And you can test that function on its own, and it's just beautiful. And basically, the blue function is a pure function. It, given the same input, it will return the same output, and it has no side effects. And there's various definitions, there's varying definitions of what a pure function is. This is Wikipedia's definition. It's kind of my definition. I like it. So, you get the idea. And pure functions, again, easy to test. And I did like all these slides and then remembered threads. Threads are a thing. Threads exist. Pure functions are thread safe, like out of the box, right? Maybe the sneetches, depending on how badly you do your threading, the sneetches, if it's a const ref, there could still be another thread modifying the sneetch. That would be bad. But conceptually, at least, it doesn't modify anything. If no one else is modifying this niche at the same time, it's very close to thread safe. It's pretty happy. And you can do local reasoning on a function that takes some inputs and returns an output. You don't have to know what the rest of the program's doing. You don't have to know anything else. If we go back to this, a function that has a body, is the one function I have as an example. You could read this function if I filled in the last little bits of it, and you wouldn't have to know anything about my program. You just look at this one function. Does it do what it's supposed to do? Great. That's all I need to know. I don't need to know anything else outside this function. And there's been some recent research in this area. Does anyone know DJ Wheeler? He's Patrice does. He's worked with Bjorn, and there's some recent breakthrough research on this area, and it's a 2-page. That's it. That's all it is. 2 pages. About this thing called a subroutine. Maybe you ever heard of them. And right at the top, first line, man, self-contained part of a program, an entity of its own. Allows the coder to concentrate on one section of the program at a time without the overall detailed program continually intruding. And it can be coded and tested in isolation from the rest of the program. This is awesome. This is like the best invention ever. 1951, recent is kind of a relative word. And he was actually Strup's thesis supervisor. So I'm a little bit sarcastic here, but like, it feels like bleeding edge. This is like bleeding edge research because I look at code and I'm like, wow, we could have self-contained pieces of a program. Did you know we could have self-contained pieces of a program? But you look at your code and are we the baddies? Like, where's these nice self-contained pieces? They'd be awesome. And I kind of think functions are fundamental. More fundamental than classes, and more fundamental than whatever other, memory's kind of important, things like that. But, without functions, you're not doing much.
Item 6 on the agenda, the meaning of life. Now, Harry, you've had some thoughts on this?
That's right, yeah, I've had a team working on this over the past few weeks, and what we've come up with can be reduced to 2 fundamental concepts. 1, people are not wearing enough hats.
Yeah, people are not writing enough functions. That's what he said, right? I think that's what he said. Meaning of life. All right. I should probably talk about member functions. How about we make is facing north why don't we take this function and make it a member function of projector? That solves our problem. We can, when we're coding, we can just type projector dot and we'll see the function come up. It'd be beautiful. Hey, look, is facing north. The function exists. Great, that's just what I needed. Maybe cameras. Maybe we also need to know if the camera's facing north, so we can just member function that baby up. Right? Great, awesome. They're both devices, by the way. Both cameras and projectors in our code base are derived from device. So maybe it's a I don't know if it's virtual or not virtual. Maybe it's overridden, maybe it's not. Maybe they both just share the implementation that's inside a device. And all devices can face north or not. This is great. I got a media server device. Media server plays media, right? It doesn't have a direction. It just plays, it's got, the direction is the cable that comes out of the media server, goes to the projector, pushes pixels. Doesn't really have a direction. No problem. We can do this. Directional device, derives from device. We got, media servers are not directional, they're non-directional devices. Maybe we have a class for that as well. At some point, going down a path I cannot follow. Just assume you know. I don't even have to put the words down or anything, right? You just know the picture, right? I hope. Okay. So if you want to share implementation, you can, use base classes. Or here's a crazy idea. You can write a function. You can just write a function that multiple things call. Functions are for sharing. And just if you could still have, if you wanted to have the member functions, you could still have the member function, but they could all just call this free function, if it works for them. You don't have to build a hierarchy and put things. I had one student, brilliant guy, but everything he was great at refactoring everything into a class called common stuff things. He didn't know what it was. It was just the common stuff. But, it was common, but when you don't know what it is, you start questioning. But he was a student. He figured it out. He was became principal scientist at Adobe, I think, or something. That's what happens. Yeah. So, I don't like refactoring hierarchies for the sake of sharing implementation. And by the way, whenever I say don't in this talk, I mean rarely. I don't mean never. When I say never, I mean rarely. But what about we just put it on orientation? It doesn't make sense to be on projector. It's kind of specific for a projector, but orientations are all about orientation. So we could just put this function on orientation. Is it facing north? Within a tolerance. Or it could be a free function. Which is better? What's the difference? The compiler has No difference at all, right? I even went to, you got to have the God bolt. I didn't put it in the slide, but I went to God bolt, trust me, and it comes out the same code, right? Like it's literally the same code. You pass an orientation in, like especially when it gets inlined, it just becomes the same code. So they're isomorphic, right? They are the same. But your classes just get weighed down and weighed down with these things that you just attach stuff to your classes. And they're made, classes are made of Velcro. You just keep adding to them forever. It's nice, the usability of, in the IDE, if you can type foo dot and see what member functions there are. But that's like a short-term usability, and I think it's long-term detrimental. This is actually very close to real code. I wonder what I took out. I mean, if this isn't embarrassing enough, I wonder if it was more embarrassing originally. Yeah, that's about it. This is the camera class, because it has everything you ever want to know about a camera. Its definition is camera stuff, all of it. And you'll notice that there's a bunch of different kind of pieces of camera stuff that probably should be separate. But they're all put together in this one class, and the class becomes a nexus of complecting. You've put stuff close together. You've put a bunch of stuff close at hand. You've made it easy to blend, mix stuff together. And you know that every time you want a new, you add one more thing to this class, and every time you add something to this class, you risk breaking the rest of the class. But you've brought all these things together. And yeah, they are kind of related, but they're not that related. So, the difference between these two left and right, one uses the external API and one accesses the internals, right? One is more likely to break in the future. They could be exact same implementations today. But in the future, if you change something about orientation, I just find that people often make a change that, I'm changing the internals parts of this class. And I know this class, so I'll just change the internals. I won't change the external pieces of the class. But then that means you have to check all the functions that have access to all your internals, right? Whereas if is facing north is an external function, you probably didn't change the external interface of your orientation class, especially if you put half the functions outside of it and kept it nice and small. So one of these pieces of code, the compiler thinks these pieces of code are the same, but one is gonna survive better. And I have this thing of good code, good code works, that's important. But good code begets good code. And I need to put the works in there because otherwise it's kind of a circular definition, and like bad code begets bad code. And good code begets good code. And you're like, well, what's the difference between the two? Well, one of them works, one of them eventually stops working, even if it kind of works right now. It's, so it's actually, to a certain extent, you don't know if code is good until later, right? Did it survive some amount of time of change and stuff? But there's signs of whether it's good code or not. Had something else to say there? Maybe not. But, two ways good code becomes, if you think of all the words you could say, like, is this good code? And you're like, is it maintainable and readable and blah, 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 and blah, 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 right? They end up going into a couple of categories. One is, does it work? Including, is it performant and is it, correct and all these things. The other one is it maintainable? Can I change this code? And the other one is, I'm on to the third hand now. The other one is, can I write new code that uses this code, right? So there's the internal, does this code beget itself to stay good over time? And does it cause the code around it to be good, right? This is a great API, it's easy to use, it's hard to misuse. That causes good code outside of this code. But both of those is good code begets good code. And the other thing I knew I needed to mention somewhere in here, invariants, right? I don't want everything to be, you can't have everything be an external function. You do need member functions. They're great, they're awesome. We just got too many of them. Obviously start with your invariants. What's your class do, right? What's it maintain? I love when I talk to potential students and stuff, and just simple things like a point class. And they're like, oh, it's gonna be private and have a get X and get Y and blah, blah, blah. And I'm like, all right, what's the relationship between X and Y? Is there certain X's, X has to be less than Y, they both have to be in the same quadrant, or is it like any X value is valid and any Y value is valid? And they're like, yeah, any value. Like, okay, maybe not nan, but let's ignore nan for now. Basically, the point class has no invariance. You could just change X and Y. It doesn't need member functions. It's just a struct, right? But then maybe the orientation class, especially if it's like quaternions, which are the thing you should use for orientation, you don't want to be changing X, Y, Z, W in your quaternion individually. Let the quaternion do that for you. Ask the quaternion to rotate itself. Ask the quaternion to do what quaternions do, because it has invariance to maintain. Most likely that X squared plus Y squared plus Z squared plus W squared equals 1. Then you get a nice quaternion on the unit hypersphere. So take your arm and do this. You make a sphere, and then do that. That's the fourth dimension. I did a lot of animation software once with quaternions. Has nothing to do with this talk, but always have this in the back of my mind. Again, this is not new. Scott Myers, 2000. That's a while ago. I remember when this came in. It seems counterintuitive. Non-member functions improve encapsulation. You should go read this article. Not right now. I do have another question. How many string functions are there?
57.
You're talking about member functions. Yes? No. How many string functions are there?
42.
This is my question. Is it Aleph not? Or is it another infinity? Is it countable infinity or uncountable infinity? Because why?
Because you could have it recursive, right? You could have the function that takes like a second order.
Well, your computer is finite. Come on, come back, come on. We're not done. Computer is finite, but time. Time might not be finite. This thing could return the digits of pi. Could just keep going forever and ever. Kind of forever, like, probably your computer will die, might still be finite. Anyhow, we can discuss this after. The point is, there's a lot. There's a lot of functions on a string. Which ones should be member functions, right? All right. I gotta move a little faster here. Yeah, I'm not totally, this is an exaggeration. It's not the never thing, right? It's just, we have too many member functions. All right. You say you'll change the param direction. Yeah. What do I mean by direction? I mean that, right? I mean in-out, right? You got some parameter, it's an in parameter, and then someone's like, we could fix this by making that an in-out parameter. And that's just another code smell. That just rubs me the wrong way, right? I want input and a result, pure functions. Now you have this case, this is where, often a reason for people doing this, it's like, I don't want to copy the vector. If it's a construct, it's fine, but like maybe I'm, it used to be hard to return a vector from a function. It's not anymore. That's all there is to it. There's nothing, it's easy. You just return a vector and it doesn't make any copies. It's a thing of beauty. You know? And you don't even have to call a standard move. It just works. Just moves the vector for you. There is one case where, maybe I'm calling this function in a loop. And in that case, I kind of do want to do it this way. Does that make sense to anyone? Right? I want to reuse the memory of the vector. Clear doesn't free the memory. It just, puts itself back at saying there's no items in it. So you get to reuse that same memory over and over in a loop. But why not both? Let's give the bottom function for the average case, the nice and easy case, and the top function for when you need performance. It's not hard to write both. One just calls the other one. Nothing to it. And the difference is, one of these I know what's going on just by looking at it, right? The first function, the left-hand side, I'm like, what's being changed? What's going on? What's being modified? Because once you start writing functions that don't modify things, you just assume functions don't modify things. And on the right-hand side, I look at that and I assume that et cetera, whatever that is, isn't getting modified, because that's how I write functions. And it's obvious that f has a really bad name, but it makes a vector. I can probably guess what it's doing if I knew what et cetera was. It's like, I take this thing and I get a vector. Okay, it's like transforming it into a vector somehow. Any better name than f, I could probably guess what it does. The one on the left is a little harder. I don't even know what's being modified. I don't know what's going on. And, if I'm trying to figure out what's going on because I'm debugging or something, man, I like the one side better than the other. I can just, don't go down that, don't go look into that function. It's probably not where the problem is. If it's not modifying anything, its result can be wrong. Look at what it returns. Maybe that's the bug. But if you're looking for who changed this variable or something, don't go down there. Don't go look at that function. It doesn't change anything. So that's params. And speaking of names, calc star pause. That didn't fit on a slide, so, calc star positions. I like calc and find and determine and words like that for functions that do stuff. Get doesn't do anything. Get's got to be fast. Maybe get area multiplies width and height, but get star positions because it actually does a bunch of work and calculates and is n squared or some crazy thing. Don't call that get, right? Even find. If find is more than linear, call it slow find. I don't know. Call it something else. And once again, you don't need the param type in there. It's for Sneech. Yes, it's a Sneech. I can see it. All right. I know what you're thinking. You're sitting there. You're thinking to yourself, you're thinking Tony, which is a funny thing to think to yourself if your name's not Tony. But you're thinking, Tony, these are fake examples, right? These are just silly little examples. What about real code? If we work in the real world, we work on real code, why are you giving me this crappy examples? This is real code. This is one of my favorite things to do is go search for step 1 in a code base and just be sad how often you find it. And how often you find this exact same step 1. This one says step 1, turn, blah, blah, blah. That shows up 3 times in our code. It's been copied. But even if it hasn't been copied, just the fact that you've got a function that has 4 or 5 steps, right? Anyone heard of this guy named Sean Perrin? Maybe, yeah. Maybe you heard of him? Yeah. No raw loops. I asked Sean one time, I actually tried to get a quote from him of what's your one thing that you would like to, tell people about coding. I wanted him to say a shared pointer is as good as a global variable, because that's one of his other quotes. I really like that one. He's like, no raw loops. And I was like, how do I write code? I write loops all the time. He's like, no raw loops. And it took me a while to figure out, but this is a raw loop in the middle of a function that's doing a bunch of stuff. It's got a loop here. Take that and put it somewhere else. This is step 1. Call it step 1 if you want. I don't care. But, it had some description in the comments, so figure out a name for it. Look, bam, there's a beautiful function. And I often find a for loop, you're either going to take the whole for loop and make it a function, or take the body of the for loop and make that a function. Or if not both, why not both? but it's a good sign of like, especially if you got a function that's got 3 or 4 for loops in it. Separate that out. And look at this one. It's not even called step 4. We know what to do with this one, right? It's just sitting there waiting for you. More real code. Kate mentioned Jonathan. He most likely fits her checkboxes of good programmer. People rely on his advice. I've seen his code. He's got good code. I think he cares about good code, if I remember all your things. Close enough. He has this good article. You should go read it, not right now. And the question is, you've got an event system, right? Event comes in and you want to do stuff, whether it's like on what to do on a mouse click or what to do on some signal, Qt signal slots, any kind of event system, right? And you could store these events as like foo is an event and it's got 3 things that want to receive the foo, right? So you got a vector. Foo maps to a vector of people who want to know about it or things. And bar maps to a vector. Or you can do a multi-map. So you'll have foo multiple times in the map with 1 entry each, right? Just 2 different ways to build your thing. And that's what his whole article's about. It's kind of interesting, nice little article. And here's the code for when foo is a map to a vector. Kind of makes sense. Gets the iterator and then gets the second is the vector, blah, blah, blah. I added some comments to it. Here's the case of the multi-map. You got to call equal range, and then you go over that. And the reason why this thing was really interesting to me is because he called this thing event mediator, and it takes an event. And I wrote the same class. Like, I called mine mediator. I didn't call it event mediator, whatever. But it's like, I was like, wow, this is so close to what I just wrote. And then I was like, oh, I'm going to go look at my code. Right? I got lucky. Tell you, I got lucky in this one. I like this code. I didn't realize I was expecting different. I don't need the comments. It's pretty obvious. The non-blocking notify, by the way, is very much like, there's threading problems. Every notification system in the world's got threading problems. This one tries to be very clear. Don't do anything in the notify. That's why it's called non-blocking notify. Just do the minimum, because it's not creating new threads. This is why we need executors and everything. So which data structure am I using? Yeah, I don't know. I don't even remember. Right? Details change and abstractions remain. Not forever, but they last longer, right? Go to Guy's talk on abstractions. Here, you can take my quote. You got a quote for your talk right there. Yeah, there you go. This is my new quote for the day. I didn't have this yesterday. At the high level, these functions do the same thing. So, and I find what happens often is people, as soon as they're inside a class, they drop to low level. Okay, I'm in the class, I can do whatever I want. It's like, no, you're in the class, you could still be 1 level removed from your own class, right? This function in the class has access to the data structure that stores it. But it's like, I don't need it. I just need to get the listeners, right? Even though I could just go at it and, access the thing directly, just call a function. Just because, I don't like picking on other people. This is my code. It's a lock-free code. No raw loops, eh? Yeah, I got a few. It's kind of, I didn't realize how ugly this code was until I started, doing a talk on it. So I'm questioning my own. Here's another one. Unnamed committee member. Wondering why don't I have a Lambda inserter thing? And basically what we're trying to do here is turn a Lambda into a back inserter, so that you can pass it to things that expect an iterator, which is like a back inserter, blah, 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 blah. And then they said, I need to write this instead, right? It's like all this code. You have to make a class just to have the pushback, because their function wasn't called pushback, it was called add or something. And then they can use back inserter to turn pushback into an iterator. It's like iterator star iterator equals, this is how all the STL works. Write the functions you want to see in the world. It's just another example of the same thing. You know, I don't care which one you write. There's two ways to do this. Write the thing that turns a lambda into an iterator for every time you write to the iterator, it calls the lambda. Or write a sample function that takes a function that is called on every sample instead of taking an output iterator. Either one is just like, this is the function I need to solve my problem. Just write it. Don't be like, why doesn't this function exist? Just, if you want a function, write the function. And this is just like 2 days ago code. This function, I mean, when I first looked at it, I'm like, here's another function that doesn't take the thing it needs. It pulls the thing it wants out right at the beginning. It wants a data set thing, whatever that is. The reason we're doing this, this code worked until we wanted to thread it, but it's got this state thing. And, you know, now at work, I'm just like, dog, fridge, what are you doing? Why are you, you know, what this function needed was a data set. Why doesn't it take a data set? I mean, it's worse. It's not even like taking state and then pulling data set out of it. It actually just has state all the time, and then it pulls it out. And you'll notice the first thing it does is it clears the data set because it's going to replace it. This is literally a void function that should return a data set. That's what it does. It builds, whatever a data set is, it builds one. Yeah. This is like complecting made easy. This class has a state that holds the world, and so you just use it. Right? So, you know, sometimes I think about this problem of we're refactoring this code now, and people are like, well, we wouldn't have known, you know, you can't refactor in advance. You refactor after. You just write some code, and we can refactor and improve it later. You know, we can't predict how this code is going to be used and how we're going to need to refactor it. And I'm kind of like, no, you don't need to do that. You don't need to predict the future. All these things, you can look at code as soon as you write it and see this code is already on the wrong path. Especially that every week I see code that's like, I took a parameter, but that's not what I wanted. I just needed this other little thing, and it could have been a nice function that was reusable, but instead I take the world, and now I have to build a whole world just to call the function.
What was that about hats again? Oh, people aren't wearing enough.
So your advice about write both functions, where one of them takes the output because you need it for performance. Do you really trust your users to know when they need performance?
No. In my case, my set of users is small, so I will tell them. I see every line of code that goes through or that gets checked in. So and I would say that's true for most teams. There's somebody on your team that can, you can be that person. You don't have to be that person for, your whole company. Just be that person for your team. Of like, hey, wait, you didn't need that. Right?
How would I encourage my colleagues and my interns and my senior developers to try to adopt it when they are just trying to fix the thing?
You catch them later. What I mean by that is, it happens all the time. I do it, we all do it, right? You write some code, and you're like, okay, great, that fixed it, good, let's go on to the next thing. I was working at Adobe, and we were on a project that was 6 months behind, right? And we were just killing ourselves you know, we got to get this done. We're so far behind. I was new there. The whole, like, this team was all new. So we're like, you really want to be successful. And then 6 months later, we were tripping over all the crap that we had put in the first 6 months behind. We were still behind. And we were now running into all our shortcuts, right? So often, partially to get code for slides, and partially just, I love when I see, you know, that opportunity for someone to learn, right? It's like, they're like doing something, you're like, hey, look, remember that code you wrote 2 weeks ago? You're bumping into it right now. This is, feel the pain. Like, you know, I don't know what else. You know, invite me to come to your business and I will